In this separate video, I'm going to just go through our adjustment factors for shear and bending. And as a reminder, table 4.3.1 summarizes these two equations for FB prime and FV prime. I'll start with CD, the load duration factor. We always want to take this as the shortest duration load, so that would be in turn our highest load duration factor. And it comes from a table in section 2.3.2 of the NDS. For our distributed load, we'll take a CD of 1 because that is our associated CD for a live load. And for the point load, we'll take a CD of 2.0, which is the associated value for an impact load. And do note, this would be reduced to 1.6 if our lumber or our timber was pressure treated, but in our case, we are using a species that is inherently water resistant and we are not pressure treating via incising, so we'll be using the 2.0 factor. CM is our wet use factor, and that comes from the NDS supplement table 4A, and that's going to be 0.85 for bending and 0.97 for shear. However, we can adjust our bending value up to 1.0 because we are using a low capacity wood, or our FB times CF value is less than or equal to 1150 psi. And that's in the first note in this table. CT is our temperature factor, and that's in section 4.3.4, and we'll take this as 1 for both shear and bending. And you can think of temperature factor as almost rarely temperature factor will apply. This is, say, in the case we're using our wood or timber in a sauna, that would be when the temperature factor is applying, but in normal outside conditions, the temperature factor will almost always be 1. Next is our incising factor, and what I mentioned above, because we are not going to be pressure treating by incising, this is in section 4.3.8, we'll take our incising factor as 1 for both shear and bending. Now moving into the factors that are bending only, we'll take our beam stability factor from section 3.3.3 as just 1 because the conditions don't apply. Our size factor, CF, from 4.3.6 tells us to go to table 4A, and because our depth is less than 4 inches, we'll go to table 4A in the supplement. If we are using a wood crossbeam, this is different, but for the wood deck board with a 2-inch depth and 8-inch breadth, we have a size factor of 1.2. With a 2-inch depth and a 6-inch depth, we have a size factor of 1.3 for the W3E detail. Right, and the larger board is the W3 detail. Next, we have CFU, which is our flat use factor from 4.3.7. Because our beam is loaded on the wide face, we get a CFU value of 1.15 for the deck board and 1.1 if we're using a wooden crossbeam. Now, finally, CR, our repetitive use factor. You want to be careful. Sometimes this value is already included if you're reading values off the decking tables, which is table 4E in the NDS. But because we did not read these values off the decking tables, we will also apply a repetitive use factor from section 4.3.9. And that is going to be 1.1.5 for our deck boards. And that does not apply for cross beams, so it will be 1.0. But this is because our boards are being used as decking and they're spaced under 24 inches on center. And finally, we can compare our capacity to our demand, which will be compared by our demand of lowercase f to our capacity, uppercase F prime, and that will be our DCR, or demand capacity ratio, which is really similar to just a calculated factor of safety. And we want to make sure that is less than or equal to 1. So we have less demand than we have capacity. So we are under 1, we are not over our capacity.